Hi, I'm Lance Hawks, a Senior Solutions Architect at CMI, and I'd like to talk to you about the IBM Flash System storage solutions and how it can be a game changer in your environment. We live in the day of now, where we want all information ready at our fingertips at all times. The data centers made tremendous transformations in the past 30 years to give us instantaneous access to data, with increases in CPU and memory speeds, and with the miniaturization of components. While we've been living by Moore's law, which states that the number of transistors or integrated circuits doubles about every 2 years, and thereby doubles the speed of processors, the hard drive, however, has been the dinosaur that refuses to adapt. It's one of the very few mechanical components that still remain in the data center. The hard drive is made up of spinning platters. These platters rotate at speeds between 7,200 and 15,000 RPMs. The spinning of those platters introduces something we call rotational latency. All the while these are spinning, you have a read-write head that sits on this arm that seeks back and forth across those platters. That seeking introduces something called seek time. So both the seek time and the rotational latency add additional latency to these mechanical devices that are still in the data center. A 72 or 7,500 RPM spinning disk will only offer about 75 input-output operations per second, while a 15,000 RPM disk can deliver roughly 250 IOs per second. We've learned strategies to combine many disks together and stripe the data to take advantage of disk parallelism and deliver much higher IOs. However, the number is still paltry when compared with a single solid-state disk or flash memory. With solid-state disks, also called SSDs, and flash storage, data is stored in microchips and does not rely on mechanical factors for access. This storage has become ubiquitous as mobile devices utilize this storage. That kind of demand for mobile devices has increased competition in the market and the price has dropped, making that technology accessible for nearly all applications. So how does SSD differ from flash storage, and why should you consider one over the other? An SSD is usually in the same form factor as a hard drive. The difference is there's no spinning disk and no seek arm. It uses microchips to write to. And in that same form factor, it plugs into either a 6 gig SAS or SATA interface. Sometimes you can connect an SSD to a USB interface, mostly found in the consumer market. On the other hand, IBM Flash storage solutions can be accessed by either 4 8 gigabit fiber channel connections or 4 40 gigabit quad rate InfiniBand connections. While the SSD and flash memory are comparably fast, the pathway to the SSD is much smaller and limits the amount of data that can traverse that path, manifesting itself as latency. SSD is by no means bad, and IBM has many products that use SSD like the DS8000, XIV, the SAN volume controller, and the StoreWise V7000 storage subsystems. We here at CMI have performed benchmark tests with SSD storage and we're pleased to realize 75,000 IOPS with roughly 3.5 millisecond latency with very few SSDs. However, for those applications where ultra-low latency is a priority, like big data applications of business intelligence and business analytics, and especially financial applications where millions of dollars are made or lost in a fraction of a second, flash storage is often the best choice, and it's ready to perform. IBM Flash systems deliver 6.7 times more capacity in a single rack than comparable storage, 19 times more cost efficiency in dollars per IOPS, and are 115 times more energy efficient, featuring a no single point of failure architecture with variable striped RAID sets to protect the data. The IBM Flash System 820 provides 20 terabytes of storage in a single rack unit. And with a IBM trademarked micro latency that's less than 100 microsecond access times. This type of low latency puts the disk layer access now on par with CPU, RAM, networks, and buses in the data I/O path. Imagine filling a single cabinet or 42 rack units with IBM Flash Systems 820 with over 840 terabytes of capacity, utilizing less than 13 kilowatts of power and accessing that data with less than 100 microsecond latency. Engineers and researchers at the IBM Hursley Development Lab in England and the Almaden Research Center in California has set a record in storage speed, outperforming the current rate by more than 250%. By combining flash solid-state technology and IBM's storage virtualization technology, the researchers were able to transfer data at more than 1 million input-output operations per second. Now that's a game changer. For another case study on how this has been implemented here at CMI, I'm going to turn the time over to one of my cohorts.
Hi, my name is Ben Kazan, and I'm one of the solutions architect at CMI, and I specialize in power systems and system storage. I'm here to talk to you about one of the hottest storage technologies out there today, which is a flash-based system, which Lance just gave an overview a few minutes ago. And to share with you some of the benefits of a flash-based systems, I'd like to share with you one of my customer experiences. So we have one of the customers approached us, and they have this new project to build a new ERP system. Now, they also wanted to reduce the number of Oracle licenses that they'll have on this new power servers, but at the same time, they want to maintain the current I/O performance that they have. So let's look at what they have right now currently on production on their ERP system. So what they have is a physical server right here with 5 CPU cores connected to a Brocade fabric talking to an EMC array. They already have performance benchmarks ran on these configuration, so we asked for the results and also the Oracle AWR reports. Now, the Oracle AWR reports is just a detailed analysis of the database performance on this system. After reviewing the reports, we concluded that the I/O was the major bottleneck in system performance. The CPU was waiting for a lot of high I/O weights. Okay? So the customer either have to buy more spinning disks to satisfy the I/O requirement or get something faster. And that's when we introduced the flash-based system. And we did a POC with the customer. So what we did was they have an application and database that's running on this EMC array. And what we did is we put in the flash-based system over here, and we copied over the data, the application and database over here. Now, the customer wanted to see initial performance, raw performance of this flash-based system, and they were able to achieve around 500,000 IOPS on this system, which was pretty impressive. Okay? So after that, we moved on to the normal workload, and we ran it with the same system configuration, and we were still able to get the I/O performance that they're looking for, but this time using less CPU. So we went through the exercise, and we removed 1 CPU core and ran the same workload. And again, we were still able to get the I/O performance that we're looking for. So we kept removing CPU, 1 more, 3, 2, and we left it to 1. And still, we were able to get the I/O performance that we were looking for with 1 CPU. So basically, with a flash-based storage system and 1 core, the system was able to deliver the same number of transactions compared to 5 cores running on this EMC array. And that's not the end of it. Since we reduced the number of cores on the physical server, we'll be able to remove 1 physical server from the configuration for this new ERP sizing that we did for them, thereby saving them an additional 300,000 in savings. Okay? So, in conclusion, our customer was able to get the I/O performance that they're looking for this new high I/O performance workload application that they're going to be running, and was able to reduce and maintain costs. That's about it. Well, to learn more about IBM Flash System or storage, you can find us on the web at cmi-inc.com or on Facebook, Twitter, or LinkedIn at CMI. You can also reach us at info@cm-inc.com. Thank you very much.